Today's lab is a bromination of trans-cinnamic acid. Cinnamic acid comes in two forms, trans and cis. Trans because carboxyl group and phenyl group, they are trans around the double bond. So when you brominate it, you must have learned from your lecture that bromination occurs in the anti-fashion. In other words, one bromine atom adds from the front and the other atom adds from behind. So in the anti-fashion. So that's why this bromine you see up and this bromine down. Now, the way I have written this formula is an erythro configuration. Erythro configuration is defined as the similar groups. They are on the opposite sides. For example, bromine here, that bromine there. This is up, that's down. This kind of formula where you have wedge bonds and hash bonds, that kind of formula is called a perspective formula. So perspective formula is the best formula because it's just a picture of the molecule. Now this is plus minus. Plus minus means that this is this is one enantiomer, but the other enantiomer where this will be up and that will be down is also produced in equal proportion. Therefore, it's a racemic mixture which is indicated by plus minus. This is a sign of rotation. All right, so but the overall mixture doesn't have any rotation at all. Now let's make this molecule in the lab today. We basically this is the apparatus setup. We take a round bottle flask, 100 ml, and we fit it with the Cleason adapter. Cleason adapter has two openings. One opening is the condenser, and the other opening is taken by the separatory funnel. This is all basically that you need to do. You need to clamp it with the lab stand, and this is the heating mantle which is connected to the variac temperature control. Now you need to set the temperature at low temperature because you'll be using DCM. Okay, so now we are going to do the experiment. So we take 2 grams of cinnamic acid and we dissolve it in 20 ml DCM in this round bottle flask. So this is a solution of 2 grams in 20 ml. And what is here? We charge this separatory funnel with 9 milliliters of bromine solution. We make the solution for you, so all you gotta do is just measure 9 ml. Be careful about bromine. Bromine is very corrosive, so you should be wearing gloves. Okay. All right. So we have 9 ml of bromine solution and 2 gram and 20 ml of DCM here. Now you start stirring or start refluxing. Refluxing means heating to boiling, right? When you boil, the vapor go up and they get condensed. So your evaporation and condensation keeps on going, and you don't lose the solvent. So you basically heat it or boil it for about 30 minutes, and during this time you add bromine slowly. Okay. So you should take about 4 or 5 minutes adding 9 ml of bromine, and at that time you actually start counting the time 30 minutes from there. And after 30 minutes, you should see a white precipitate visibly inside the flask. Okay, so your experiment is done. All you gotta do is turn the heat off and disassemble the apparatus, remove the separatory funnel, remove the Cleason adapter and the condenser, and finally the flask. Okay, so it should be still a little bit warm. You cool it down in ice water mixture. The purpose of cooling down is to get more and more precipitate, because the white precipitate is your product. All right, so after cooling it for about 10 minutes, we are ready to filter the product during suction filtration. Okay, so in suction filtration, you use the Buchner funnel and you add a filter paper, filter disc. You wet it with DCM, and this is the filtration flask with the side arm. And you apply vacuum and vacuum pulls down only the DCM, but it leaves the product on the filter paper, and then you basically wash it. The way to wash it is you turn the vacuum off and put some 4 or 5 ml of DCM and use a glass rod to agitate it. All you're doing is you're rinsing the crystal of the DCM. So DCM will dissolve any unreacted material or any side product that might be formed. So DCM will come down after filtration. After that, you basically keep applying the vacuum for about 10 more minutes, and then you are done. So you assume that your product, which is white crystals on top of the filter disc, are there. Now you need to use a spatula to disconnect or detach these filter paper along with the product and transfer it to a wash glass. And by the way, your wash glass and the filter disc should have been already weighed. And find out the mass of the product. And in order to find out the percentage yield of this reaction, you need two dimensional equations, one for the bromine and one for the cinnamic acid. And you need to find out the limiting reagent. Based on limiting reagent, you calculate the percentage yield. And that's all. That's all you report in your lab report. So, okay, let's head right to the hood and do the experiment. Let me introduce to you the reagents that we'll be using in this reaction. This is bromine solution, bromine dissolved in DCM, dichloromethane. And this is a trans-cinnamic acid. This is a powder. And I have measured 9 ml of DCM to dissolve cinnamic acid. And this is bromine solution that I am using 4.7 ml of this solution for this reaction. And this is the round bottom flask, 50 ml or 100 ml, and you can add trans-cinnamic acid to it. I'm using a powder funnel. And then I'm adding dichloromethane to it. Dichloromethane really doesn't dissolve anything. It doesn't dissolve cinnamic acid. So we have to actually heat it to about 50 degrees so that it can dissolve, and then we can do the reaction at that temperature. And for that we can just use hot water from the running water. Okay, so we have been trying to dissolve this cinnamic acid in DCM. It's a little bit difficult to do that, but if you heat it at 50 degrees or 55 degrees using a condenser, with the condenser you have to circulate water from the lower port and the water should leave from the upper port. So we are basically refluxing this using a water condenser. So this solution is being heated. So hopefully it will dissolve at 50 degrees. Please disregard that label 5% sodium hydroxide. This has nothing to do with it. I forgot to remove that label. Okay, so now we can add at 50 degrees a bromine solution, 4.7 ml that I measured, and we take about 5 minutes to slowly add it. This reaction has an incubation period. That means it takes a little bit of time to initially start. Once it starts, then it takes off, and then it goes quickly. So we added the entire solution in about 5 to 6 minutes. You can still see that's still orange, but it will convert, the orange will go away. Okay, we are back in the lab, and I can see it has become white now. You can see precipitate over there, white precipitate. That's your product. But we are not sure if the reaction is complete or not. Maybe there are still some double bonds that are that need to be brominated. So we just want to make sure that we have a little bit excess bromine, so that we are sure that all the double bonds have been taken by bromine. So we will add just a tiny bit, maybe about half a ml more of benzene, and then watch for the color to go away or remain behind. And if it remains behind, that means the reaction was already complete. So we can see that, there's a little bit of orange color. Orange color is because of excess bromine. So we'll wait for about a couple of minutes to see if the color goes away, and it did not go away, so that means the reaction is complete. Now we are dismantling everything, removing the thermometer, removing the round bottom flask from the condenser, water condenser. Make sure you put the water condenser away safely, and you can see this orange color. That means the reaction is complete, and now we have a little bit of orange color because of excess bromine. So the first thing that we need to do is just remove the stir bar with a magnet retriever. Magnet retriever removes the stir bar safely, and now we're going to cool it. It was not very hot to begin with because remember, we were just heating it at 50 degrees. So we cool it in ice water mixture, and we also pre-cool some DCM, dichloromethane, that we have to use later for washings. So the big beaker has a small beaker. The small beaker contains dichloromethane, and we are just basically cooling that, and because we need this solvent later on for washing our precipitate or the product. The best way to cool it, swirl it for several minutes, or just leave it there. And we have now filter paper, filter disc in there in the Buchner funnel. Make sure it covers all the holes. You press them, and just press, make sure it covers all the holes properly. Now you add the DCM to it to wet it. Don't use water, just use DCM to wet it. And what wetting does is it actually covers the holes. It makes sure that since the filter disc becomes wet, so it covers the holes much better. So you apply vacuum to it, and you drain whatever DCM was in there. Now the filter paper is wet. It's ready to take the precipitate. So it has been cooled for about 5 minutes, and we have gotten some more precipitate, and you can see it's still orange, and so it just ensures us that there's some excess bromine in there. We need to actually kill off that bromine by a couple of drops of some compound that has double bonds in there. Right now we are using 1,5-hexadiene. 1,5-hexadiene is a little bit smelly, so make sure when you're using it, you are aware of the smell. Alright, so you swirl it and pour back each time you put a portion of the suspension onto the Buchner funnel, you must swirl it. Now you add you can see that there is no color in the filtrate. That means that the double bonds have been excess bromine has been destroyed properly. There's a little bit left in there, and so that's why we have this pre-cooled DCM. It's a good idea to use pre-cooled this DCM. We don't want to lose our product because of this little bit of solubility in DCM. So DCM should be cold. So you do that, the washings. The best way to wash it, or rinse your precipitate is the following. What you do is basically you just do that a couple of times when the vacuum is still on, but then turn the vacuum off and disengage the Buchner funnel from the vacuum. It may take a little effort, and then add cold solvent, in this case dichloromethane. And remember, there's no vacuum right now, so the DCM is actually sitting on top of the
precipitate. So basically just agitate it, make sure you don't injure, you don't damage the filter paper. Just for about 30 seconds stir it and then apply vacuum again, and you can do that 2 or 3 times. Each time you turn the vacuum off. And now look at that, it's a very nice, beautiful precipitate because it has been washed uh, properly. So you leave it there for several minutes on the vacuum to make sure that there's no DCM left over there. And after that, you disengage the filter paper and the product onto a watch glass. Now watch glass and filter paper, they were weighed together in the beginning. So this filter paper that you see was already a part of the mass with the watch glass. Okay, so you make sure you transfer all the white precipitate as best as you can, and then we are ready to mass the watch glass and the filter paper with the product, because we need that to calculate the percentage yield. As usual, we are back to the whiteboard, and we have reacted trans-cinnamic acid with bromine and we got an erythro 2,3-dibromocinnamic acid. This is the very specific stereochemistry, erythro, not 3O. And we have now the data. We started out the reaction with the 1.8 gram of cinnamic acid, and with the mass of watch glass plus filter paper is 49.12, and with the product it is 50.64. So we got 1.52 gram of the product from 1.8 gram of cinnamic acid. So you can calculate the yield for this reaction. By the way, this bromine solution that we used was old solution. I think the solution was not very good. I think the bromine solution should be prepared fresh. Anyway, when you do the reaction, you should use the fresh solution of bromine. You should be getting better yield. So how to characterize the product? You just take the melting point. The melting point of the erythro is more than 200, and for the 3O is less than 95.